Welcome to Lavanya lectures. Now I have to explain data structures. In the data structures, the concept is BST, binary search tree. So I will explain what is binary search tree. Binary search tree is also known as BST. So what is BST means? First BST is a binary tree. So first BST is a binary tree. So what is tree? Tree means tree contains roots and also edges, root and edges. Tree is a combination of nodes. So node is represented with a circle diagram. So it is a tree, it contains number of nodes. So in these trees it is a specially designed node, it is called as a root. One root node contains any number of childrens, these are called as childrens. Okay. If any root node have either 0, 1 or maximum 2 nodes, then it is called as binary tree. So what is binary tree means? A tree with 0 nodes, 1 node or maximum 2 nodes are called as binary tree. Now we will go for binary search tree. So what is binary search tree? Binary search tree is a tree and also it is a binary tree. So binary search tree, first of all, it is a binary tree. So after that, now you are including some nodes. So how can you include the nodes? Means every tree has a root node. After that it has left children and also right children. But which element is keep it in the left hand side and which element is keep it in the right hand side? For that we have to follow some properties. So what are the properties for binary search tree? The first property is tree may be either empty. Tree is either empty tree, or it contains some children. If it contains children means either it may be 0 or 1 or maximum 2. Then we take anything left hand side children. Left hand side children compulsory less than the root node. Left hand side children is compulsory less than root node, and right hand side children is compulsory greater than root node. So these are the properties you have to follow for developing a binary search tree. So first of all, the tree is either empty, then also it is called as binary tree. Either way binary search tree, otherwise it contains some children. If that binary search tree has children, then either the tree may be either it left hand side or right hand side. Which children are kept in the left hand side means the left hand side elements are always less than the root element. That means the elements, which elements you want to keep it in the left hand side, all the elements must be less than its root node. And third property is all right hand side elements compulsory greater than its root node. That means which elements you want to keep it in the right hand side, all elements must be greater than the root node. So these are the properties of binary search tree. Now we will explain with one example. Take some numbers and then how to draw a binary search tree I will explain. Now I am explaining with one example how to construct a binary search tree. For that I have to take some elements like 100, 50, 200, 300, 20, 150, 70, 180, 120 and 30. For these elements now I want to explain with how to construct a binary search tree. So these are the elements. In these elements the first element is 100. So 100 is considered as a root node. So 100 is considered as a root node. So root node is in first binary tree is empty. So it is a tree is empty. So it is considered as a binary tree. And the first element, whatever the first element in the given list, that is 100. 100 is considered as a root node. Okay. Then it is a binary tree as well as binary search tree. Then second element, consider second element. So in the list, which one is the second element? That is 50. So take the 50 and compared with its root node. So what is its root node? The root node is 100. So 50 is smaller than 100. So the next element 50 is smaller than its root node. So according to binary search tree property, the which element is less than its root node is compulsory keep it in the left hand side. So 100 left hand side of root node, take it as 50. So this is the binary tree as well as binary search tree. Then go to second element. So which one is the second element? The second element is 200. Again same procedure, it is a repeated recurrence procedure. Again start with the root node. So in this example, which one is the root node? The root node is 100. So what is the next element? The root node is 100. So what is our new node? The new node is 200. Again compare 200 and 100. 200 is more than 100. That means the new element is more than its root element. So according to binary search tree, it is keep it in the right hand side of root node. So 200 is traveled through its right hand side of its root node. So 200 is the keep it in the right hand side of its root node. So this is the binary search tree. Then go for third next element. What is the next element? The next element is 300. Again start same procedure. Again we always start with its root node. So the root node is 200. So compare 100 and 300. 300 is more than its root node. So go to right hand side. Again right hand side is again one more node is there. So in this binary search tree we have to maintain the left. The children is also every time considered as a binary tree formula. So again here whenever we come into right hand side, the right hand side 200 node is available. Again check, that means it is a subtree now. It is a subtree. Again same rule applied for subtree also. So again 200 is considered as a root node and the new node is 300. 300 is greater than 200. So according to BST properties, it is also going to right hand side of 300. So this is the property. First root node. The left hand side of 100 is 50, that means smaller than 100. And right hand side element is 200, that is more than 100. Again coming to 300. 300 is more than 200 as well as 100 also. So up to this binary search tree properties are satisfied. Next element is 20. Apply same properties. Compared with, again from the beginning you have to start your creation. So again starting node is 100, root node 100, compared 100 and 20. 20 is smaller than 100, so go to left hand side. If you coming to left hand side, here one more subtree is there, node is there, that is 50. Again compare 50 and 20. 20 is smaller than 50. So go to left hand side of 50. So now 20 is inserted left hand side of 50. Okay. Next element. What is the next element? The next element is 150. Again start the procedure from 100. Compare 100 and 150. So 150 is more than 100. So go to right hand side of 100. And here right hand side one more node is there, that is 200. Again compared with 200. 200 and 150. So 150 is smaller than 200. So go to, according to binary search property, go to left hand side of 200. So 150 is inserted left hand side of 200. So this is the binary search tree. Now we go to next element. Which element is the next element? 70. Again we apply the same properties compared with starting root node, that is 100. 100 is more than 70, that means 70 is smaller than 100. So go to left hand side. Here left hand side the new element is 50. So compare 50 and 70. If you compare 50 and 70, 70 is more than 50. So go to right hand side of 50. So 70 is inserted right hand side of 50. So this is binary search tree. The next element is 180. Again procedure starts with root node. Compare 100 and 180. 180 is more than 100. So according to binary search tree, have to go to right hand side of 100. If you are coming to right hand side of 100, there one more node is there. The node is 200. Then compare 200 and 180. 180 is smaller than 200. So go to left hand side. If we coming to left hand side, the left hand side one more tree is there, that is 150. Again compare 150 and 180. 180 is more than 150, so go to right hand side of 150. So 180 is inserted at the right hand side of 150. Okay, next 120. The next node is 120. Again start with the procedure from the root node. The root node is 100. Compare 100 and 120. 120 is more than 100. So go to right hand side. The right hand side one more node is there, that is 200. Compare 200 and 120. 120 is smaller than 200. So go to left hand side. Left hand side node is 150. Compare 150 and 120. 120 is smaller than 150. So go to left hand side of 120 and insert the new node 120 is at the left hand side of 150. So then last node, the last node is 30. Again follow the same properties. 30 and 100. Compare 30 and 100. 30 is smaller than 100. Go to left hand side. The left hand side the new node is there, that is 50. Compare 50 and 30. 30 is smaller than 50. So according to BST properties, coming to left hand side of 50. Here 50 one more node is there, that is 20. 20 and compare 30. 30 and 20. 30 is more than 20. So go to right hand side of 20. So after taking all these elements, this is the binary search tree, the complete binary search tree. That is starting node 100. Left hand side of 100 is 50, that is smaller than 100. And right hand side children is 200, that is more than 100. So both the right hand side children, one is smaller than 100 and another one is 200, that is more than 100. Next, if we coming to, this is a subtree, and again the subtrees also follow the same properties of BST. Here considered subtree 50 is a root node. The 50 has two children, 20 and 70. 20 is smaller than 50, that's why it is in the left hand side. 70 is more than root node 50, that's why it is on the right hand side. If we go to next level, 30. 30 is more than 20, that's why it is on the right hand side. But it is smaller than 50, that's why left hand side of 30. So like this we can construct the binary search tree.